All right, in our lesson today, we're going to talk about factoring higher order polynomials. So the first thing we're going to do is we're going to factor the expression, and then we're going to use the factors to sketch a graph. So let's see how that works. So if we take a look at letter A, notice that they have a GCF. We always want to pull out a GCF if they have one. So I'm going to take out 3x, and that leaves me with x squared minus x minus 2. So now I'm looking for factors of -2 that add up to -1, and I think that's going to be x minus 2, x plus 1. So those are my factors. Now we're going to use those to find the zeros, and that's going to help us with our graph. So first of all, we find out what makes 3x equal 0. Divide both sides by 3, and you get 0. X minus 2. What makes x minus 2 equal 0? Well, that would be 2. So I'm going to put a point at x equals 2. And what makes x plus 1 equal to 0? That would be -1. Now, this was a third degree, a cubic function. So I know my third degree functions start down and then end going up. So all I have to do is fill in the gaps, and there we go. It doesn't have to be perfect. We just wanted the right idea of when does it go up, when does it go down. So the next one also has a GCF of x. So we'll just factor out the x. And then we have x squared minus x minus 20. So now I'm looking for factors of -20 that add up to -1. So I'm going to use -5 and +4. So we're going to do the same thing again. We're going to find out what makes each one equal to 0 and put those on our graphs. Because remember, the zeros are the x-intercepts. So what makes this one equal 0? What makes this one equal 0? And what makes this one equal 0? So those are the points I'm going to plot. 0, -4, +5. So once again, I have a cubic function with a positive a value. So that goes down and ends with up. And then I just connect the dots. And that's the basic shape of my graph. So you don't have to put it in your calculator to get the exact points. We're just looking for a sketch, somewhere close. All right, how about this one? 2x squared plus 6x. What do they have in common? I'm going to say 2x. And if I factor out 2x, I'm left with x plus 3. So that's all the factoring I can do. What makes 2x equal to 0? And what makes x plus 3 equal to 0? So there are my roots. Now this is an even degree with a positive a value. So that means it's going up on both sides. So it looks something like that. One more. 10x squared minus, this is actually problem D, minus 50x minus 60. Notice they all have a common factor of 10. So that leaves us with x squared minus 5x minus 6. Now you have to be careful with this one. 6 is kind of tricky because we've got, for 6, I could do 1 times 6 or I could do 2 times 3. Now it's easy to go, oh, 2 and 3 add up to 5, but this is a -6. So one of these has to be negative. So if I use a -2 and a +3, I don't get a -5. But let's switch this around. If I use a +1 and a -6, that would give me a -5. So be careful there. X plus 1, x minus 6. Now, in our others, we factored out an x. So we always tried to make this one equal to 0. But can I make 10 equal to 0? No, there's not an x there. So that part's done. My only roots, my only x-intercepts are going to be from x plus 1 equal to 0 and x minus 6 equal to 0. So I've got -1, positive 6, and it's an x squared, so it's a regular parabola with an a value that's positive. So it's up and up again, something like that. All right, in the next section, we're going to factor by grouping. I think I'm going to do letter C. And then for your homework, you can do A and B. So take a look at these. Now, we've talked about grouping of just putting them all in the box because I've got my 4 terms. But before we do that, do you notice a GCF anywhere? Always be on the lookout for a GCF. So I'm going to take out an x, and that'll leave me with 6x to the third plus 24x squared plus 5x plus 20. Now these are the numbers I'm going to put in my box now that I've factored out that GCF. So here goes. Let's see what we've got. 6x to the third, 24x squared, 5x, and 20. So what do these two have in common? 6x squared. What do these two, the 5x and the 20, have in common? I go with 5. Now let's go vertically. 6x to the third and 5x. That's just an x. And then 24x squared and 20. What do they have in common? If you're not sure, you can look over here and go, well, 5 times this number has to give me 20. 6 times this number has to give me 24. So that helps you to pick out that it's a 4. So my final factored answer is x, 6x squared plus 5, x plus 4. Now, sometimes when we have an x squared left in our answer, it can be factored further. In this case, 6x squared plus 5, we're done. There's nothing else we can do. And that is our final answer. So that's just a refresher over factoring by grouping. Now, number 3. This brings us something kind of new. I'm going to take this one, letter B. Because this one is still, 3A is still grouping, but be careful to notice it does have a GCF when you come back to it. But letter B, we haven't had to factor like x to the 4th minus 10x squared plus 9. So let me just ask you this. What if it just said x squared minus 10x plus 9? Could you factor that? Can you find factors of 9 that add up to -10? Well, I hope you're thinking it's x minus 1 and x minus 9. So the difference between this one and this one is it's x to the 4th instead of being x squared. So the only thing that's going to change, instead of saying x minus 1, I'm going to say x squared minus 1 and x squared minus 9. So x to the 4th splits into x squared times x squared. And then if I go through and multiply it all out, I do get a -10x squared in the middle and a plus 9 in the back. Now the question's going to be, can I factor this further? Well, x squared minus 1 looks like a difference of squares. And hopefully you're really familiar with this one and you're like, oh yeah, that's x plus 1, x minus 1. Well, what about x squared minus 9? Can that one go further? Yes, it can. X minus 3, x plus 3. So when your directions say factor completely, you take it as far as it will let you go. If this had said x squared plus 1, you're finished with that one because it has to be a difference of squares to break down like this. All right, on the next page, there's something similar. Let's do letter C. It says x to the 4th minus 16. So remember we talked about our difference of squares. something squared minus something squared. Well, x to the fourth is something squared. It's x squared squared. And 16, of course, is 4 squared. So in my formula, when I do a plus b, a minus b, I'm going to plug in x squared for a and 4 for b. So watch what happens. I've got x squared plus 4 and x squared minus 4. Now this x squared plus 4 is done. It is not a difference of squares. There's a plus there. So that's done. X squared minus 4, however, can be broken down further. So that's x plus 2, x minus 2. And now I have factored completely. So be on the lookout for a difference of squares right here. But if it's a plus, it's not a difference of squares. It has to have a minus, like this one did. And then you get to do letter D. Let's do a couple on the bottom page, and then the rest of it is your practice. So here's just a quick review of our rules. Now, instead of writing two separate rules, this is all written as one. So notice from here to here, it's the same sign. And then this one is always the opposite. And this one is always positive. So hopefully you've got this in your notes. If you want to write the two separately, you can. You go plus, and it's plus minus plus, or if this is a minus, you go minus plus plus. So we're just going to apply the sum or difference of cubes to these first two. So let's do letter E. Remember, we had to identify, what am I putting in for A? Well, in this case, it's an x and a y. But in our notes, we did A and B. So 8x to the third, A should be 2x. 27, B should be 3. And then we plug them in. A minus B, remember, same sign, A squared plus AB plus B squared. That's just a refresher on our sum and difference of cubes, and the same is true for letter F. Let's do a couple more, and then you get to practice. Look at letter C. 3x to the fourth plus 2x squared minus 8. All right, so we're just going to do this in our box. Because as soon as you see a number in front of x squared, you're thinking, I should put this in the box. So we're going to multiply 3 times negative 8. That's negative 24. Can we find factors of negative 24 that add up to 2? I'm going to go with positive 6 and negative 4. Now, when you put these in here, I need an 6x squared, because that's what this says, x squared, and a negative 4x squared. And we'll just take out our common factors like we always do. On the top row, they both have a 3, and they both have an x squared. On the bottom row, I'm going with negative 4. First column, I think it's x squared. And the second column, I'm going to go with a 2. Because 2 times negative 4 is negative 8. So to be factored, I'm going to write 3x squared minus 4, and then x squared plus 2. Now x squared plus 2, I know I'm done because that's a plus. Now this one does say minus 4, but notice that 3x squared is not a perfect square. So I'm done. That's all I can do for this one. All right, let's do one more. Let's do letter F, and whatever didn't get done now becomes your practice. So take a look at letter F. Do you see a common factor? I see some x's. They all have 2 x's, and they're all divisible by 2. So I'm going to factor out a 2x squared, and that should leave me something pretty easy to factor. X squared plus 5x plus 6. Oh, we talked about 6 earlier. Remember, it could be 1 times 6 or 2 times 3. Notice this is a positive 6, so they're going to be the same signs. If I add 1 and 6 together, I get 7. If I add 2 and 3 together, I get 5. So I'm going to use 2 and 3 this time. So x squared, just x, plus 2, no, that is x minus, plus 3, sorry. And there is my factored completely. So whatever we didn't do in the notes, you're going to do for your practice. Be sure to ask questions if you have them.